In our last chapter, we talked about ratios and proportional relationships, and we learned how to solve proportions and to use proportions to solve a lot of proportional relationship problems. We're going to kind of continue that theme in chapter 6, where we're going to be talking about exclusively percents and how to solve percent problems and apply percents to real world situations. So today we're going to talk about using the percent proportion, and that's a proportion that's used to solve percent problems. So percents are ratios, and they always make a comparison to 100. So you can always write a percent as a fraction or as a ratio, so we can use them in proportions to solve them. So on the screen here, I've got a bunch of examples of percents written as ratios or written as fractions. So 50% is 50 out of 100, 25% is 25 out of 100, 37.5% is 37.5 out of 100, 0.3% is 0.3 out of 100, and 140% is 140 out of 100. Notice these are always out of 100. So it's very easy to turn a percent into a ratio by just simply comparing it to 100. So again, that percent proportion, it's a proportion that contains ratios that compare the part to the whole and a percent to 100, because the 100 always represents the whole and a percent is always, well, how much out of 100 do we have? And we're always comparing that to a part and whole relationship. So this is going to be the key take-home point right here. This is the proportion we're going to be using in this video, and that's the part to the whole. So that's like a fraction comparison. And we're going to compare that to the percent out of 100. So we're always looking for the part, the whole, and the percent in our problems to see which one of those three is missing. So an example of a percent statement I have below here, 50% of 90 is 45. Well, all three parts of the proportion are present in this statement. The percent is there. That's obvious. That's the 50%. Of 90 is 45. Of 90 means that we're kind of indicating that this is the whole, or out of 90, and 45 is the part, is 45. 45 out of 90 is 50%. So we're always going to be looking for these three key parts, the percent, the whole, or the part. So we can use the percent proportion to find missing values. So I've got a bunch of examples here of missing numbers in percent problems, and we're going to see what's missing and what we know. So 15 is what percent of 20? So I've got all of the parts identified here where 15 is the part, 15 is what percent of 20. The percent is missing, what percent, and of 20 is the whole of 20. So out of 20, 15 is what percent of that. So then we just use our percent proportion, the part over whole equals percent over 100, and basically just fill in what we know. So 15 out of 20 is how much out of 100. So now we have our proportion, and then we can go ahead and use all of the strategies that we know to solve this proportion. There's a nice horizontal relationship here. 20 times 5 is 100. So 15 times 5 will tell me what my percent is, and 15 times 5 is 75. So this is 75%. So 15 is 75% of 20. 100 is what percent of 25? So again, I'm looking for the parts here. 100 is the part, and 25 is the whole. Now that might seem a little bit counterintuitive because 100 is bigger than 25. It's not always the bigger number that's the whole. So we have to really pay attention to the wording here. And usually the word of is associated with the whole, and the word is usually found next to the part. So 100 is what percent of 25? So out of 25, what percent? So the percent is missing again in this problem. So we're going to use our percent proportion to fill in what we know, and what we don't know, we'll put an X there. So the part is the 100, the whole is 25, and the percent is missing. So here we've got another proportion. There's another nice horizontal relationship here where 25 times 4 is 100. So 100 times 4 will tell me what percent that is, and that's 400%. So 100 is 400% of 25. Next, what number is 11.4% of 330? So what number is, that's going to be the part. So the part is missing. We know the percent, and we know the whole. So again, I use the percent proportion and fill in what I know and put an X on what I don't know. So I put an X in the place of the part. 330 is the whole and 11.4 is the percent. Here I use the cross products to solve this. So when you use the cross products and solve this proportion, you get 37.62. So 37.62 is 11.4% of 330. And next one, find 10.5% of 30. Well, the of here indicates that I'm talking about the whole. So 30 is the whole. It's obvious that 10.5 is the percent, so that means the part is missing again. So here we have a missing part. So I've got X where the part goes in the percent proportion. X out of 30 equals 10.5 out of 100. And then I again use the cross products to solve this. And when you do, X is 3.15. So 3.15 is 10.5% of 30. And then the last two here, 30% of what number is 63? So 30%, here the percent is known, 30% of what the whole is missing, and the part is 63. So again, I use my percent proportion. 63 out of what equals 30 out of 100. And again, I use the cross products to solve this. And when you solve this, X is 210. So 30% of 210 is 63. And then finally, 45 is 3% of what number? The part is known. 45 is 3%. The percent is known. And then of what number? The whole is missing again. So again, I have an X here where the whole goes in my proportion. And then I solve this one. There's a nice horizontal relationship here. 3 times 15 is 45. So 100 times 15 will tell me what the whole is, and that's 1,500 or 1,500. So 45 is 3% of 1,500. So that's basically all you're going to encounter. These are the only types of percent problems you're going to find where the percent is missing. And then we put our variable in the percent part of our proportion. Where the part is missing, our variable goes in the part portion of our proportion, and the whole is missing, and our variable goes where the whole goes in that proportion. So again, the proportion, a very powerful tool for solving percent problems, and we've already discussed solving proportions. So again, we're just extending stuff we've already talked about and are applying, again, this concept of proportion to help us solve percent problems.